Hello again. That was the quickest break ever. As I said before, this is Daniel Susid, and he's going to talk about .NET deserialization attacks and their associated threats in the world of content management systems. So take it away, Daniel.
Thanks.
I'll catch you later.
All right. So, my name is Daniel Susid. I've been in the security industry for about 15 plus years, something like that. And currently I work as a security specialist at Outpost 24. And my focus right now is predominantly on offensive security. So I do a lot of different stuff like penetration testing, red teaming, and similar stuff. And application security is a big part of that also. And this is the first time I'm in Cold Garden, so it's very interesting to see. It's very nice and relaxed. So, deserialization attacks. Oh, okay, great. Thank you. All right. So, I don't know if anyone here is interested in security, but deserialization attacks are a very, very common thing these days. But it's not a new thing. So, from a Java perspective, it was already a concept in 2016. But James Forshaw introduced it in terms of .NET serialization attacks already in 2012. So, it's been here for a long time, actually. And Alvaro Munoz actually introduced it, or he did a lot of research in that area, and he really put it on the center stage in 2017. So why talk about deserialization attacks? There's been a lot of recent events with attacks in this area. It's quite high level of complexity in terms of understanding these type of attacks. And often they are quite misunderstood. It's easy to think they're too complex, it cannot happen to us, or we just don't understand that we're vulnerable. And the actual impact of an attack is very high. I don't know if you recognize this. Anyone? I put this here on a purpose because I think this really, really made the headlines. It was a really big thing, right? In the Java world, everyone knows Log4j. Everyone uses Log4j. And if you don't use Log4j, then you're probably not a coder. And very soon after the first vulnerability came, we had 5, 6, 7 more vulnerabilities coming really, really fast, all concerning deserialization type of attacks. But this is the Java world, right? This is Java, this is not .NET, and we're talking about .NET serialization attacks. So what makes that interesting? Does anyone recognize this? We had 4 0 days in Microsoft Exchange, right? So why is this interesting? For one, I was working in a SOC at that time, and it was crazy. I tell you, I was afraid. My manager was crying, and things were happening all over the place. But there is a specific purpose why I'm actually mentioning this. So if you look at the Exchange server exploit chain here, you can see on the center stage, actually, you have a .NET deserialization vulnerability which is used. The attack used for the Exchange server attack, which was exploited by, for example, Hafinum, a Chinese threat actor, it was quite sophisticated, and it was a very complex exploit chain consisting of several different exploits. So you had a service-side request forgery type of attack going on, and then a file write, arbitrarily file write going on post-authentication, and then they used actually .NET deserialization to actually escalate to system privileges. So I would say this really puts .NET on, or .NET deserialization type of attacks on the map, for sure. So what about CMS, right? We're in the Umbraco world. We talk about CMSs. Do you recognize these? These are .NET focused. So, I mean, there are lots more in different languages, in Java, in PHP, and so forth. But if you just focus, if you just look at the .NET side of things, these are quite recent. You have a deserialization type of vulnerability in Orchestra, which is a very popular CMS. You have a pre-auth RCE type of deserialization type of vulnerability in Sitecore, and so on and so on. So we can't really say that it's not a common thing right now, right? It's still happening. So we have to be aware, we have to keep it in mind. I know everyone here is a developer, so, or maybe a manager, post-developer, whatever, but still, you do know what serialization is. But I'll still do a recap. So we're basically talking about marshalling an object, converting an object from, from a structured object to a format that maybe it's more human readable, or it's easier to transfer over the network, or store in the file system, and so forth. And then you have the reverse order, right? You have the deserialization part, which is basically reconstructing the object and use it again as an instance. So when you look at it, I mean, the flow is not too complicated, but of course there's a lot of complexity underneath. And the big issue here from an attack perspective is the deserialization part, right? When you're actually reconstructing the object. But deserialization doesn't make your source vulnerable just by using it. You can implement deserialization in a secure way, right? And it's more a matter of actually how you use it and a combination of factors, how you configure the libraries that you use, and if you consider other aspects, if you are using untrusted data for one. So basically, in terms of when we talk about insecure deserialization, it means that we have certain conditions that allows a user to actually inject an object into the marshalling process or the deserialization process. And if you can do that, the outcome is quite simply, you can do a denial of service type of attack, you can do a remote code execution, or you can just manipulate the logic in various ways. So the big thing is, can the attacker control the object? Can the attacker control the type? Right? And of course, in .NET and so forth, you need to have a deserialization gadget, so-called, right? It's like a trampoline that can actually execute a method. So if we look at it from a simple perspective, this is a typical, very common library, JSON.NET. And in this case, we're actually setting the type name handling to objects. And you can find this in a lot of places. If you look at the open source code bases, you see this a lot. It's very common. And because it's easy, the code, when you want to deserialize an object, it automatically determines the type. So it makes things very easy. But there is a pitfall here. What happens when you can automatically determine the type from the actual data that you are consuming and deserializing? And if an attacker can actually control that data, then you have a deserialization issue. Then you have insecure deserialization. This is a very normal, typically structured JSON object. For example, if you would deserialize an object, it would look pretty similar to this. But there are some things here which are a little bit different. And if you look at this object, this is actually a malicious object in terms of if an attacker would send this to the previous method, which has type name handling set to object, which means it actually determines the type, it would actually instantiate not the type that maybe was set in the code from the beginning or expected in the code, but to the type actually specified in the actual JSON. And there's another aspect here. If you look at it, you have something called the object data provider, right? So that's a wrapper class. And that wrapper class, usually call it a gadget, right? And that gadget we can use to actually execute another type of instance method. For example, in this case, we are executing the start method of the system diagnostic process class. You couldn't do this, you couldn't just instantiate the system diagnostic process and execute the start method by itself. You need to have a gadget, right? You need to have a magic, so to say, class or magic function. And the object data provider class is quite special in that way because it actually, as soon as it actually gets the object instance set, for example, like in this case, the system diagnostic process, it will, after instantiating that actual class, call the method name, which is provided here, the start, and provide the method parameters. So in this case, we can actually execute code while performing deserialization. So, the code I just showed you, a very simple example, this one here, where you actually are setting type name handling to objects when performing deserialization, was actually found very recently, just about a year ago, 2021, in one of our most popular CMSs, Orchestra C1. And you can see a little bit of a screenshot here of the actual code and how it's set. So it's set to type name handling equals 4, right? So that is the same as type name handling dot objects, right? So a very simple thing like this made or created a vulnerability in the CMS which actually allowed executing remote code on the server post-auth, though. You needed to be authenticated. But still, you can actually execute code on the server just by sending a request that will be deserialized. An interesting aspect, actually, in terms of this is also, when you look at this code base, they're actually using something which is called the composite serialization binder here. And one of the usual recommendations to address the issue with deserialization and types and so on, and restricting the types that can be deserialized, is to use a serialization binder. However, in this case, which is quite interesting, they did actually implement a serialization binder, but they only restricted the actual assembly names or type names or namespaces that conform to their namespace. Anything else outside of that was okay and was completely unrestricted. So you could pretty much deserialize anything that you wanted. So if we look at a hypothetical attack scenario in the context of a CMS, I'm sure today everyone is pretty accustomed to this, but if we just look at it from an amusement point of view. So as an attacker, right, so you have a vulnerability. We mentioned like site core before. These are pre-auth vulnerabilities. You also have the Kentico CMS vulnerability from 2019 as an example. .NET deserialization, pre-auth. It's extremely easy for an attacker to cause huge amounts of damage. And there's a lot of information, and there's a lot of threat intelligence about threat actors actually using deserialization type of attacks to gain the initial foothold in a corporate environment. It's very, very common. So if we look at this scenario, the attacker would basically just use the .NET deserialization attack. It's pre-auth. He doesn't need to be authenticated. He can just send a request. He's on the server. He's executing code with the same privileges as the server. And he can then escalate to system, perform lateral movement, and do whatever he really wants within the company, right? So it has a lot of implications. There should be a lot of awareness about this. So if we look at another hypothetical attack scenario, for example, if we look at the post-auth type of vulnerabilities that we have, for example, in the Orchestra CMS. So we have one from 2021, and we have another one from 2019, right? So the one from 2021 is the one actually with the type name handling configuration, set a little bit in a strange way. So if you look at it from this perspective, you can see that it's not that difficult to abuse this either. There is a little bit of a higher threshold here for an attacker, but still you can really abuse this. For example, as an attacker, you could obtain leaked credentials, so you can actually access the server. It doesn't have to be high privilege credentials, it can be low privilege credentials, so you can actually access the CMS, and then you can actually perform post-auth type of deserialization attacks and get access to the server. But you can also perform this kind of attack, which is post-auth, through a CSRF type of attack, cross-site request forgery attack. And you can combine that with social engineering. So when you actually combine these kind of post-auth vulnerabilities with other type of issues, you get a very complex, sometimes complex, but very efficient and very effective exploit chain. And in this case, for example, it wouldn't take much for the attacker to actually be able to abuse this to get a foothold within the infrastructure, just like in the pre-auth type of attack. And the same type of procedure, you get access to the server, you're inside the perimeter, you can do privilege escalation to system, and then start doing various types of lateral movement through Active Directory or whatever. So how do we prevent this kind of things? Well, one thing is to avoid deserializing untrusted data. I mean, of course, we're going to be using deserialization, right? It's really a really nice feature, and it's really helpful for many things. But we should try to avoid deserializing untrusted data as much as possible. But if we really need to deserialize untrusted data, we should really try to evaluate the security of the libraries that we use. And we should ensure that the libraries that we use, that they have strict type control. It's also important to try to ensure that the library-specific options that we use, for example, like the type name handling that we looked at before, that it's actually set according to best practice. And also try to consider various implications of various configuration settings. It can get complicated sometimes. That's why white box reviews, code reviews are really important. It's not always easy to find these things through just static analysis. It's also important to do dynamic analysis and various code reviews overall. So a combination of these three aspects is really good. And one thing, which is really, really important, never use user-controlled data to actually define the type which is expected by the actual deserializer. This is also another aspect that we see, just actually quite common, to be honest. Even when we talk about different kind of formatters, not only JSON formatters like JSON.NET, it can be XML, serializer, whatever, binary formatter, and so forth. Another aspect is to use class whitelists, use serialization binders, but when you do, be very careful and review the implementations, and as I said, go back to the beginning. If you can, avoid deserialization of untrusted data. That's the key. We're going to have a workshop on Friday where we're going to be going through these RCs here, for example, the orchestra C1 CMS RC, and another one also. This one is from 2021. We're also going to go through the one from 2019, and we're going to actually be going through the whole code base. We're going to be performing and creating our own test payloads and performing various types of attacks to try to see how to abuse this. And also a little bit in terms of how we actually would approach it from a perspective when we only have a closed source project in terms of actually reverse engineering the actual software at hand. There is a lot of other information you can get. OWASP has great cheat sheets. You can read a lot about deserialization issues and how to avoid them and how to actually stay safe. As I mentioned Alvaro Munoz before, he is really one of the leading people in this area. And he has a lot of nice information that he has written out and research published. And you can read a little bit about what James Forshaw already mentioned in 2012. And yeah, that's it. Thank you.